So what have we looked at so far? So far we've looked at solving polynomials by factoring. We've looked at solving polynomials if I give you a factor, and then we can get down to doing the quadratic formula. Now we're going to say, if I don't give you something that's a factor or a root, how can I solve it if it doesn't factor originally? So what we're going to do now is we're going to need to have our calculator. So if you don't have a calculator, go pause it and go grab a calculator. My first step is I'm going to do my P's and Q's like we did in the previous video. So remember, my P's are factors of my constant term. So that would be factors of 2 are 1 and 2. Factors of Q, that's factors of your leading coefficient. That just means your number in front of your highest degree. So that would be plus or minus 1. P over Q means I put everything in that first list over everything in the second list. So 1 over 1, that's just 1. 2 over 1, that's just plus or minus 2. Do you need the plus or minuses? Yes. What does it mean for P over Q? If you're still a little mystified, is that these are my only possible rational solutions. What do I mean by that? These are the only possible rational numbers that could make my equation equal to 0, or the only places it crosses the x-axis at a rational number. So we're not talking about irrational, we're not talking about imaginary, and we're not saying that all of these work. So what we're going to do now is use our calculator to see if any of these work. So we're going to type your equation over here into y equals. Then we're going to say second graph, and that takes you to your table. And I'm just going to copy down where my table is showing up a few of these numbers. And when I do that, here's just where my table started. Yours may be a little bit different. What I'm looking for in my table is for a y value of 0. So here I have that I get a y value of 0 when x is negative 2. So if I write this in function notation, f of negative 2 equals 0. And now we pick up exactly where we were in the last class, where now I can say if f of negative 2 is 0, then that means x plus 2 is a factor. And now I can divide my original polynomial by x plus 2 and do the quadratic formula. So I'm going to clean stuff up on this page and divide by x plus 2. Do you need to write down the part with the table from your calculator? Absolutely not. Here's what I need you to write in this problem. I need you to write that f of negative 2 equals 0. So then we're going to divide by x plus 2. So x plus 2 is a factor. Put it on the side, x plus 2, and I zoomed in too much. I can't actually see my function. There we go. So first term is x cubed. I need to see this division. So that would be x squared. 2 times x squared would be 2x squared. I have 2x squared. I want 7x squared, so I need 5x squared. Now I say, what times x is 5x squared? That would be 5x. 5x times 2 gives me 10x. I have 10x. I want 11x. I need 1x. Repeat the process. What times x is x? 1. 1 times 2 is 2, which is exactly what I want. So you should always have this so that it divides evenly. If it didn't divide evenly, check how you typed it in the calculator. Check that from here to here your sign changed. Those are the things where usually we might get tripped up. And now that I have this first part, we're going to set that equal to 0 and do the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Man, it all comes back, doesn't it? All right, so I get -5 plus or minus square root of 25 minus 4 is 21 over 2. If I try to do a factor tree, I get 3 and 7, which is not going to go anywhere. So here are two of my solutions. That's coming from the plus or minus. And then my other solution is -2. Once again, I'm dealing with a cubic, so I should have 3 solutions. All right, so now let's look at our P's and Q's for the next ones. So P is your factors of your constant term. So I have 1, I have 5, I have 7, I have 35. Q are your factors of your leading coefficient, so 1 and 2. And P over Q, I put the first list over the second list. So I always do over 1 first. That means I just copy and paste all my P's. Those don't change. And now I'm going to put them over 2. So I have 1/2. I like to just put this in another row. Then I have 5 halves. Then I have 7 halves. And then I have 35 over 2 halves. So the only possible places in my table where I could have 0 showing up in my y column are one of these numbers. So if it's not showing up at one of those numbers, then it doesn't have any rational roots. We're not getting into that in this class. We'll do that in pre-cal. All right, so we're going to type that in to your y1. So clear out what you had before. Type this in, second graph, and get your table. All right, I had to scroll up and down a little bit more than the last problem, but I scroll in my table and I see -6, -59, and then I have -5 and 0. Once again, I don't need to see your table, but I'm just showing it so you can see whether you have the right thing timed out. So I have -5 equals, f of -5 equals 0, which means that x plus 5 is a factor, and I'm going to divide my original by x plus 5. First term, first box, helps if I put the 2. What times x is 2x cubed? That would be 2x squared. Then I'm going to do 2x squared times 5, 10x squared. I have 10x squared. I want 11x squared, so I need 1x squared. Do you need the 1? Nope, I'm just trying to show all my work. Okay, what times x gives me 1x squared? That would be a 1x. Multiply 5x. I have 5x. I want -2x, so I need to take away 7. What times x gives me -7x? That would be -7. And 5 times -7 is -35. Yay, that worked. Remember, in all of these, it should divide evenly. All right. So since I've got that, my whole goal in life is to get to something that's a quadratic because I can do quadratic formula. What if you don't get to a quadratic? We'll talk about that in a second. All right, so x equals opposite b plus or minus square root b squared minus 4ac all over 2a. I simplify that and I get 57 over 4. And I can't simplify square root of 57 anymore, so I have my 3 solutions. I have that one plus or minus gives me 1, and then I have that x is -5. All right, this one's for my honors people. Notice this time I'm starting with x to the 4th. So that means what I'm going to do on this one that's different is I'm going to look for 2 roots in my table. I'm going to look for 2 places where this is 0. So let's do our P's and Q's real quick. Factors of 4, 1, 2, and 4, all with plus or minus. Factors of my leading coefficient, just 1. P over Q ends up just being my list of P's. So the only possible places in my table where I get 0 are going to be +1, -1, +2, -2, +4, or -4. Those are the only numbers that I need to check. So let's type that in the calculator and see if you can find in your table 2 numbers where your y column is 0. I got that in my table y is 0, at 1 and 2. So what that means is that x minus 1 is a factor and x minus 2 is a factor. So I'm going to divide twice. I'm going to divide the first time with x minus 1. I could have started with the other one, but I'm just going with x minus 1. And then I'm going to take that answer and divide that answer by x minus 2. All right, so I'm not going to go back to my original for the second part. All right, so let's go back to my original up here. First term, first box. So it would be x cubed, negative x cubed, have negative x cubed, want 4, so I need 5, x cubed. So it would be 5x squared, negative 5x squared. I have negative 5, I want negative 17, so I need to go down 12. So it would be negative 12x, positive 12x, have 12x, want 8, so I need to take away 4. So that would be minus 4, positive 4, yay, that worked. So once again, now I'm going to divide by the x minus 2, but I'm dividing into what I just got for my result. So first term I'm using is x cubed. So this would be x squared, negative 2x squared. I have negative 2x squared. I want positive 5x squared. So that would be go up 7, 7x, negative 14x. I have negative 14. I want negative 12, so I need to go up 2. And I get out negative 4, which is what I want. My whole goal in life is still to get a quadratic, so I can do the quadratic formula. X equals opposite b plus or minus square root. Do you like how I'm changing the song? Yep. B squared minus 4ac all over 2a. X equals negative 7 plus or minus the square root of 49 minus 8, which would be 41, over 2. Nothing I can do to simplify that square root of 41. And I'm done. All right, so now we've looked at solving by factoring and solving when something doesn't factor. So what I always check for is whether it factors first. So we looked at two terms. Is it a difference of squares? Is it a sum and difference of cubes? Notice I actually have exactly the same examples from that first video. If it's three terms, we look and see if it's what I call quadratic form. An example, it always has to be x to the fourth, x squared, plus a constant, or we can go higher than that, x to the sixth plus x cubed plus a constant, basically that highest exponent if you divide by 2. But we're not going to worry about, these get really big, so we're not going to worry about those, just like we're not going to worry about the things to the 6th power there. So we really focus on to the 4th power. So that means in this non-example, notice I kept my numbers the exact same, but this is cubed. So since that's cubed, that means I need to go through that whole long process of using the table in my calculator if I wanted to solve that problem. So just because it's 3 terms doesn't mean it's this quadratic form. And then we have 4 terms. We can check if we use the box. Now I kind of say the problems glow if you can use the box. You can always just check, but if you notice, like these have a GCF of x squared, these have a GCF of 3, and if I take out that 3, I get a 4. Like, if you don't know what I mean by glowing, it's okay. Put it in the box, see if it works. This non-example, if I put it in the box, it doesn't work. And a lot of these are really obvious. Like, I have some weird numbers. Like, there's no way the box is going to work with that. I don't even check. Or if you want to be lazy, you can just always do the longer process. What is the longer process I am talking about? So, this is a little different than how I taught it this year. So, we're going to do the rational root theorem. That just means your P over Q. And we're going to put it in y equals, and we're going to look at the table. So kind of cross this out. Look at the table, and in my table, I'm looking for where y equals 0. We divide that out, and you repeat until you have a quadratic, and solve using the appropriate method usually the quadratic formula. Note is that you can't extend the square root method to higher powers. So I cannot solve x to the fourth equals 16 by doing the fourth root. I cannot solve x cubed equals 27 by doing the cube root. And it only works for squares.